Hello. In this video, we are going to learn about radian and degree measures of angles. So let's first discuss truly what an angle is. So an angle is determined by rotating a ray about its endpoint. The vertex is the endpoint of the ray. The initial side is the starting point of the angle, and the terminal side is the position after rotating the ray. So let's see what this looks like. Here is our ray. Now we are going to rotate, okay, that's our initial side. Now we're going to rotate this. Where it ended up is our terminal side. And where the two rays meet is our vertex. Let's discuss angles in standard position. Standard position is whenever an angle is, when the vertex is at the origin, when the initial side is on the positive x-axis. So here we have our graph. There is our initial side, our first ray. We are going to rotate this. Now we have our terminal side. So our initial side is on the positive x-axis and our vertex is at the origin. So this angle you see here is an angle in standard position. Now, a positive angle is whenever we rotate counterclockwise, which is what we just did, okay? Now, let's see what it looks like for us to have a negative angle. It's when we rotate clockwise. So now we have a negative angle. Coterminal angles are when two angles have the same initial side and the same terminal side. Their angle measures will be different, however, their ending position will be the same. So let's look at an example. Here is our initial side. We rotated this 135 degrees. Now, starting once again at the initial side, what if we rotate clockwise? Now that was a negative 225 degrees. Those are two totally different angle measures, 135 versus negative 225. However, our initial side is the same and our terminal side is the same. Therefore, the angle 135 degrees and the angle negative 225 degrees are coterminal angles. Radian measure. What is a radian measure? It's just another way of measuring angles. Radians are a special relationship between the radius and the circumference. We're not going to dive into that relationship, but please know that it is a relationship between the radius and the circumference. An entire rotation is 2 pi. So here we have our circle. Here is our initial side. We are going to make an entire rotation around the circle, and that was 2 pi radians. What happens if we only rotate halfway around the circle? Well, half of 2 pi is pi, so this is pi radians. What if we only rotate a quarter of the way around the circle? Well, that's going to be pi over 2 radians, because that would be half of pi, so pi over 2 radians. What if we rotate 3/4 of the way around the circle? Then that's going to be 3 pi over 2 radians. We're going to dive more and more into radian measures whenever we get into our unit circle, but this is just the beginning of radians. So radians correlate directly with degrees. So 2 pi radians is the same thing as 360 degrees because we know a full rotation is 360 degrees. We see at the top that is a 90-degree angle. Keep going around, that's half a circle, which is 180 degrees. And then at the bottom, we have 270 degrees. So if you see pi over 2 radians, that's equivalent to 90 degrees. If you see pi radians, that is equivalent to 180 degrees. If you see 3 pi over 2 radians, that is equivalent to 270 degrees. Now, you see in the previous slide that radians and degrees can be equivalent. So we can take a degree measure and we can convert it to radians by multiplying the degree times pi over 180. So let's look at an example. We're going to convert 125 degrees to radians. So our formula is degree times pi over 180. Well, we know our degree is 125, so we're going to replace the formula where it says degree. We're going to place a 125 there. And 125 times pi over 180 We want exact answers, so we are going to simplify 125 over 180 in our calculator or in Desmos and keep it as a fraction. You're going to get 25 pi over 36. Do not give me a decimal answer. That is nasty. That is inaccurate. We are in pre-calculus and we can attend to precision. So you are going to put 125 over 180 in your calculator, and then you're going to have a pi in your final answer. Now, just like we could go from degrees to radians, we can also go from radians to degrees. We have a formula for that as well. We're going to take the radian measure and we're going to multiply it times 180 over pi. So last time we were pi over 180. This time we're 180 over pi. So let's look at an example. We're going to convert 6 pi over 5 radians to degrees. So we know that our formula is radian times 180 over pi. But now we know our radian measure. It's 6 pi over 5. So 6 times 180 is 1080 pi, and then 5 times 5 is 5 pi. We have a pi on the top and we have a pi on the bottom. Pi divided by pi is going to divide out to 1. 1080 divided by 5 is going to simplify to 216. So our angle measure now is 216 degrees. Now, we can use all of this information to help us find arc length of a circle. So arc length is simply the length of the edge of a circle whenever there's an angle inside of it. We're going to see what the picture looks like in just a minute. The formula for arc length is S equals R times theta, and theta means the angle measure. R means radius. And our angle measure must be in radians. Must be. So we have a circle. We have an angle. Now, we are looking for the length of that circle right there. That is our arc. We're looking for the arc. So we know our radius was our initial side. Well, even our terminal side is also our radius. And then our theta is going to be the angle right there on the inside. And we'll use this information to find arc length. We're going to see an example of that in just a second. We also need to discuss finding area of a sector. So the area is going to be like the slice of the pie. The area of the sector formula is 1/2 r squared times theta. R being radius, theta being our angle measure. And once again, our angle measure must be in radians. So here we have our circle. We have our initial side, our terminal side, and we know that our radius is the initial side or the terminal side, either one. Our theta is the angle on the inside, and it must be in radians. And once we use this formula, we would find this shaded area right here. And area units are always going to be squared. So if this scenario would have been meters, our final answer would have been meters squared. Okay, so now we have an example, and we're going to find the arc length and the area of the sector of a circle. The circle is having a radius of 5 meters and a central angle of 75 degrees. So here's our circle. We know it's going to make an angle of 75 degrees, and it has a radius of 5 meters. Now, we know that this says 75 degrees. Where did my circle go? Oops. Okay, so we can't have degrees. We need it to be in radians. So we're using the formula theta equals r times pi over 180. Theta equals degrees times pi over 180. So that's going to be 75 times pi divided by 180, and that's going to reduce to 15 over 36 pi. Arc length is S equals R times theta. Now, theta had to be in radians, but we just converted it to radians. We know, oh, there was the circle. It's a little late. We know that our radius is 5, and now we know that our angle in radians is 15 pi over 36. Multiplying all this and simplifying, we're going to get 75 pi over 36, and this is talking about length, so our unit is going to be meters. Let's also talk about area of a sector, which is area equals 1/2.
This is a reminder that we are going by advisory schedule today.
Area equals 1/2 r squared times theta. So we know that our r is 5 and our theta is 15 pi over 36. And simplifying all of this, so you would say multiply 5 squared is 25, and you would multiply all that across, and then Remember, you never put pi in the calculator because we do not want decimal answers. We're going to get 375 pi divided by 72, and that's meters squared because area is always squared units. So that's how you find the arc length and the area of the sector. Most important things to note are before you start plugging into the formulas, make sure that your angle is in radians, because most of the time it will be given to you in degrees. So that concludes this video regarding radian and degree measures.